Okay, so we are going to be discussing the unit circle today and how we derive it. So I hope you have your little triangles. I'm going to start by drawing my little triangles. The whole unit circle is based on those two special right triangles that we've dealt with before. The 30, 60, 90 triangle and the 45, 45, 90 triangle. So the first thing I want to do is kind of just review those general special right triangles and then see how they are going to apply to the unit circle for us. So our 30, 60, 90 triangle. Generically, we know the relationship that we label the short side x, the long side x times the square root of 3, and then the long side 2x. That's just our generic relationship for a 30, 60, 90 triangle. On the unit circle, we know that that is a circle centered at the origin with a radius of 1. Well, what we're going to be doing is we are going to be creating right triangles inside of this unit circle. That if we have some angle measure here and we drop a perpendicular down, we're creating this right triangle inside of our circle. Since the radius of the unit circle is always equal to 1, what we're going to do is we are going to take this relationship that we know generically for a 30, 60, 90 triangle and replace the value of the hypotenuse with the number 1. So I'm going to draw myself another triangle here. And I'm going to say, well, the hypotenuse of this 30, 60, 90 triangle is 1. And now we want to get the other two sides based on the relationship that we know and the fact that our hypotenuse is equal to 1. Well, it's easiest to go from the hypotenuse to the short side, because if the hypotenuse is 2x and the short side is just x, to go from here to here, all we do is divide by 2. So on the unit circle, the short side of a 30, 60, 90 triangle is going to be 1/2. Make sense so far? Well, then to go from the short side to the long side, we take our short side and we multiply it by the square root of 3. So we're taking the square root of 3 and multiplying it by 1/2. That gives us square root of 3 over 2. So this right here are the values for a 30, 60, 90 triangle on the unit circle. So I want you to take your 30, 60, 90 triangle here, and we want to label it. And we'll label both sides of the triangle. So let's label the hypotenuse 1, the short side 1/2, the long side square root of 3 over 2. And be sure to put your angle measures in there as well. When you're done labeling your triangle, you should have something that looks like this. And again, I do both sides. Give me a thumbs up when you guys have that done so that I can move on to the next part. All right, let's do the same kind of thing now with our 45, 45, 90 triangle. And then once we get that all created, then we'll actually do something with these triangles. So 45, 45, 90, that's our other special right triangle. We know that the two sides are the same and we label those X, our generic relationship. And then the hypotenuse is whatever our X value is times the square root of 2. Well, we want to make this specific for the unit circle. So we're going to make the hypotenuse of this 45, 45, 90 triangle 1. Now it's easier to go from the short side to the hypotenuse, right? We take this and we multiply it by the square root of 2. But to go from the hypotenuse then over to the side, what would we have to do?
Divide by the square root of 2?
Divide by the square root of 2. So we're going to take our hypotenuse of 1 and divide it by the square root of 2. But of course, we want to rationalize that. And we end up with square root of 2 over 2. So that is going to be the values of our sides on our 45, 45, 90 triangle when we're in the unit circle. Square root of 2 over 2. So now you're going to take your other triangle, the one that's a 45, 45, 90, and you are going to label its sides on both sides of the triangle. And when your triangle is all labeled, it should look like this. And again, you want to do both sides of your triangle. So let's see how we actually go about figuring out what values are on the unit circle using our triangles. So I'm just going to go ahead and do the ones that are in our Trig notebook. I'm not going to share my screen because I want to look at my diagram. So hopefully have your blank circle here as well, and we can talk about how we're going to do this. All right, great. So the first value we want to find on the unit circle is sine of pi over 4. And we're going to use the same technique whether we're given something in radian or degrees. Every value that we're going to be asked to find on the unit circle without using some more complicated formula that we'll discuss later in the course is going to have a reference angle of either 30 degrees, 45 degrees, or 60 degrees. Or it's going to be on one of the axes and you're going to be able to just look with your eyes and figure out what the ordered pair is. If they give it to you in radian, I always convert it to degrees just because my triangles are based on degrees. So I at least do it in my head, convert this. So sine of pi over 4 is the same as, what does that convert to?
45 degrees.
45 degrees. So if I go on to my circle here, and 45 degrees is going to be right here. And then I'm going to create a triangle. So what happens is I end up with a 45-degree reference angle. It's all about what the reference angle is. So if my reference angle is a 45 degree, I'm just going to take my triangle and I'm going with the reference angle of 45 and I'm going to put it right there, boom, on my circle. Now, it's important that you position this triangle correctly. You need to make sure that the right angle is on the x-axis, because every time we do this, we always drop the perpendicular to the x-axis. So make sure that your reference angle is at the origin and your right angle is on the x-axis. We redefined our 6 trig functions based on the unit circle. Previously, sine was y over r, but now that our r value is 1, we simplify sine to be just y. So sine is the y value, and I can just look at my triangle and say, oh, the y value, I've labeled that to be square root of 2 over 2. So we know that sine of 45 degrees is square root of 2 over 2. Sorry, I think maybe I should have used a different color for my triangle. But hopefully you can't see it exactly, at least you're getting the point. Questions on that first example? I think I'm going to make up some examples before we do some of those more complicated ones that we have in our notebook, like secant and cosecant, just so we can get down the practice of using these triangles. I'm going to choose a different one. All right, let's find cosine of 5 pi over 6. So we're likely going to want to convert this to degrees just to help us with our reference angle. There's a 5, kind of looks like a 3. So how many degrees is 5 pi over 6?
150.
150 degrees. So 150 degrees, as we rotate, comes over here. What's the reference angle for 150 degrees?
30.
30. So this time we're going to use our 30, 60, 90 triangle, and we're going to be sure to put the 30 degree at the origin and the right angle on the x-axis. So it looks like this. And now we can use the sides of our triangle to help us find cosine. Cosine is defined to be x over r, but again, r is 1, so cosine on the unit circle simplifies to be just x, which is this part of the triangle, and we have it labeled square root of 3 over 2. The only other thing you have to take into consideration is whether these values are going to be positive or negative. When we're in quadrant 2, is the x value positive or negative?
Negative.
Negative. So cosine of 5 pi over 6, or cosine of 150, is going to be equal to negative square root of 3 over 2. And honest to God, I still do these triangles every single time. I may not like use the physical triangle, but you'll see as we start solving equations and stuff, you'll see me, okay, I'm going to make a triangle, short side, long side triangle to help me find these values. You do want to memorize the values on this triangle, that for 30, 60, 90, the short side's a half and a long side is square root of 3 over 2. And for the 45, 45, 90, that both sides are square root of 2 over 2. You do want to memorize those, but then that's all you have to memorize, and we can just figure it out with our triangles from there. I'm all about learning less and applying it more frequently, especially in trig. There's way too much to try to memorize everything. Let's find sine of 300 degrees. Sine of 300 degrees is going to be in quadrant 4. What would the reference angle be for 300 degrees?
60.
60 degrees. So we're taking our 30, 60, 90 triangle, but this time we need to be sure that we're putting our 60-degree angle at the origin and our right angle on the x-axis. So it's going to look like this. Sine is our y value on the unit circle. So looking at the y side of our triangle, what is that value?
Negative square root of 3 over 2.
It's square root of 3 over 2, but since we're in the fourth quadrant, the y value is negative, so we get negative square root of 3 over 2. Questions so far? All right, well, let's tackle some of the tougher ones. I'll start pulling the ones out of our trig notebook there. So let's find secant of 2 pi over 3. Well, secant is not on our triangles. So what we're going to do is we're just going to figure out what the cosine value is and then flip it over. I only ever work with sine and cosine on the unit circle, and then I use the definitions to convert it to the other 4. Okay, so 2 pi over 3, I need to figure out what the degree is so that I can get my reference angle. How many degrees is 2 pi over 3?
180.
120? 180 would be just pi. So 120 degrees puts us in quadrant 2. What is our reference angle going to be? It's going to be 60. So our triangle is going to be in this direction because we want that reference angle of 60 to be at the origin and the right angle to be on the x-axis. I know that secant is the reciprocal of cosine. The cosine value is 1/2. Therefore, secant is going to be the reciprocal. It's going to be 2. And lastly, we need to then decide if it's going to be positive or negative. We're in the second quadrant. X values are negative. So secant of 2 pi over 3 is -2. Questions? All right, let's try another one. About cosine of -5 pi over 6. Our angle is negative, so this time when we start in standard position, we're going to be rotating in a clockwise fashion. What's our degree measure?
150.
So we're looking at for cosine of -150. That's going to put us in quadrant 3. And we need to figure out our reference angle. What's our reference angle going to be?
30.
30. So we're taking our triangle and making sure that the 30 is at the origin and the right angle is on the x-axis. So it's going to be right here. We know that cosine is the x value on the unit circle. The x value, looking at my triangle, square root of 3 over 2. And is the x value positive or negative when we're in the third quadrant?
Negative.
Negative. So we're going to get negative square root of 3 over 2. Math is all full of patterns, and we know that. So here's a little pattern that I can help you when determining your reference angles. When the angle has a denominator of 3, your reference angle is going to be 60. And when you have a denominator of 6, the reference angle is going to be 30. It's always the opposite. And then in order for your reference angle to be a 45, the denominator in your radian is going to be 4. Because, hopefully there's going to be a point where you don't really feel the need to do the full conversion into degrees, that you're more comfortable with the radian measure. But until then, something that, convert it in and do it from there. But later you'll notice that pattern. Denominator of 3, reference angle of 60. Denominator of 6, reference angle of 30, denominator of 4, reference angle of 45. All right, let's do a couple more. Anybody questions so far? Anybody having like trouble positioning their triangles or anything like that? Knowing values on the unit circle, honestly, you got to know it like you know your multiplication facts. But understanding where they come from is going to help us actually remember them. I remember my trig teacher just said, here, look, I'm going to show you. I've saved this from the 11th grade. This is what my high school trig teacher gave me and said, here, memorize this. What in God's name is this? Right? Who can memorize that? It's crazy. Here, memorize this. Oh my God. So if we can I would much rather memorize these two tiny little triangles, understand where the values are coming from, and then I can actually get them for the rest of my life. All right. Tangent of 4 pi over 3. Well, right away, what's our reference angle going to be?
60.
It's going to be 60 because my denominator was 3. But we got to make sure we put the 60 in the right spot. So we still need to think degrees. Oh, 4 pi over 3. What's our degree measure? (240 degrees). Oh, 240 degrees is going to be in which quadrant? Third quadrant.
Third.
And we've already established it's going to be a 60-degree reference angle. So here's my triangle in this position. I know that tangent, there's two different ways we can think about it. We can say, well, tangent sine over cosine, or we can think of tangent as y over x. Our y value, square root of 3 over 2. Our x value, 1/2. Since we're in the third quadrant, both of those values are negative. Oh, our tangent here is going to be negative a square root of 3 over 2 over negative 1/2. And we want to simplify. Dividing two fractions, we're turning it into multiplying by the reciprocal. We get a positive square root of 3. Questions? All right. Let's find cosecant of 3 pi over 2. Well, let's see what kind of degrees we have there, because Allison told me what my reference angles were when my denominator was 3, 4, or 6, but not for 2. So let's get this into degrees. 3 pi over 2, how many degrees is that?
270.
270 degrees. So I need to find that on my unit circle. 90 180, 270. So 270 is right here on our y-axis. And I guess I'm just going to draw on this. So this point down here is 0, -1, since we're on the unit circle. So there's our x value and there's our y value. Cosecant is 1 over y. So this is going to be 1 over our y value of -1. Cosecant of 270 is -1. Questions on that one? Yeah, so usually when it's a denominator of 2, that means it's going to be on the y-axis. Let's find cotangent of 7 pi over 4. Do we know the reference angle?
45.
45, denominator of 4, reference angle 45. Now I just got to figure out which quadrant this 45, 45, 90 triangle is going in. 7 pi over 4. How many degrees is that? Is that 315? So that puts us in quadrant 4. Again, our reference angle at the origin, our right angle on the x-axis. Cotangent is the reciprocal of tangent. It's going to be x over y. Oh, my x value and my y value are the same, right? In a 45, 45, 90. The only thing I have to be concerned about are positives and negatives. The x value is positive square root of 2 over 2, while the y value is negative square root of 2 over 2. Well, square root of 2 over square root of 2, square root of 2 over 2 over square root of 2 over 2 is just 1, and we have a positive divided by a negative, so we get -1. Questions on finding exact values on our unit circle? Super important. Gotta know it. And honestly, you guys are going to get away. I don't want to say get away with it a little bit. You guys are going to get away with it a little bit since we're all remote instruction and you're not coming on campus to take tests, because normally you would have a test where I would, half of it would be no calculator, no formula sheet, so that you would have to show me that you actually could find those values. We're not having in-person proctoring, so we're not going to be able to have that type of testing. So you're kind of going to get away with maybe not knowing the unit circle as well as you normally would. But you guys are all headed to calculus, okay? We're all ending up back on campus sooner or later, and you are going to know this information. So take this time, honestly, not to shortcut your way through the class, but to genuinely learn this, because your calculus instructors are going to expect that you know these numbers like you know your basic multiplication facts. It's important. All right, I want to do some going the other direction. So in these next few examples, we're going to go the opposite direction. I am going to give you the value of a trig function, and you are going to tell me what the angle is. I definitely think that this is the harder direction. So we want to find all theta between 0 and 2 pi where cosine is equal to 0. We know that cosine means the x value. So we're trying to find what angle has an x value of 0. Well, if we have an x value of 0, then that means that we never get off the y-axis. So we're either going to be up here or down here. So we want to give those angle measures, and we want to give them in radian. So if I'm right up here at 90 degrees, what's that in radian?
Pi over 2.
Thank you. And then down here as well, this is our second option. So 90, 180, 270, what's that radian going to be?
Three pi over 2.
3 pi over 2. Another way to help you count, because there's all kinds of patterns in the unit circle. This is 1 pi over 4. This is 2 pi over 4. This is, oh, sorry, I said that wrong. Sorry. This is pi over 2. 2 pi over 2. 3 pi over 2. 4 pi over 2. So you can count it that way as well. All right, there we go. Next, let's find what angle from 0 to 2 pi is tangent equal to negative square root of 3. Well, if tangent's negative, which quadrants do I have to be in? Tangent being sine over cosine. So if our tangent, or x over y over x. So if our tangent value is negative, that means one of them have to be positive and one of them have to be negative. So in which quadrants is one of them, either x or y, positive, while the other one's negative?
Second and fourth.
It's going to be in the second quadrant and in the fourth quadrant. So I already have that in mind, that I got to be in quadrants 2 or 4. Square root of 3. Well, if I take a look at my two special right triangles, which one of the triangles involve the square root of 3? Well, the 30, 60, 90 triangle. So I know that it's going to have to be the 30, 60, 90 triangle, because there's no other way that I could do y over x and get square root of 3 unless it involves square root of 3. Well, now I just have to figure out, is it 1/2 divided by square root of 3 over 2, or is it the other way around? So honestly, I just kind of play around with it. And I'm like, all right, if square root of 3 over 2 is on top and 1/2's on the bottom, what's it look like? That's square root of 3 over 2 times 2 over 1, square root of 3. Okay, so this tells me that the y has to be square root of 3 and the x has to be 1/2. That's helpful because that now tells me how I need to position my triangle to get the correct angle. It's telling me that the y is the square root of 3 over 2 and the x is 1/2. So that means that my triangle has to be positioned this way. Since our tangent value is negative, we already said we had to be in either the first, or I'm sorry, either the second or the fourth quadrant. So here I am in the second quadrant with a reference angle of 60. So that means that our actual angle is 120. And I'm just going to write down the degree measure and then I'll convert it to radian later so that I'm following the directions. And now I have a second triangle, same way, where the y value is the square root of 3 over 2 and the x value is a half in the fourth quadrant. Reference angle of 60 again. So what's our actual angle measure?
300.
300. So our answers are 120 degrees and 300 degrees, but the directions asked us to put it in radian, so we need to get these in radian. Since it had a 60-degree reference angle, what's our denominators going to be? I know they're going to be 3s.
3.
I just have to figure out what they are. 20 degrees, or I'm sorry, 120 degrees converts to 2 pi over 3. And 300 degrees converts to 5 pi over 3. Questions? Yes, it takes practice to get fast at this. But having that deeper understanding, you're actually going to remember it because you need this forever. All right, let's try 2 more. You know what? Why don't you guys try the next 2? Let's find the angle where sine of theta is equal to 1/2 and cotangent of theta equals -1. All right, so if we want to figure out which angle measures sine has the value of 1/2, kind of just the evolution of my thought process from just holding on to my triangles. As soon as I see 1/2, I recognize that that is the short side of my 30, 60, 90 triangle, right? Sine is the 1/2 is the short side of my 30, 60, 90. Because I'm not always going to have these triangles in this circle here to help me, you know, like on a test. So this is kind of how I recreate it. Like, all right, well, sine is positive. That means the y value is positive. That's going to happen in the first and second quadrants. So if the y value is the short side, that means that the x value has to be the long side. So I go, x is long, y is short, triangle. X is long, y is short, triangle. And we know that small angles are across from small sides, so that means that these have to be 30-degree reference angles. So without my triangles, I have, you know, still created the same diagram, just without the physical manipulatives. And now I just have to figure out what those actual angles are. Well, 30-degree reference angle in the first quadrant, that's pi over 6. 30-degree reference angle in the second quadrant, 5 pi over 6. And again, it's fine if for now you're finding the degree measure and then converting it to radian. That is totally fine. Questions on that one?
This you should convert it to radian without.
Yeah, I know, because your book said leave it in degrees. That's fine.
No, it's okay. Just I'm asking.
Just practice. You just follow the directions. I know your book said
Okay.
degrees. Just be able to do both because I'm going to mix it up. All right, cotangent is equal to -1. I'm always excited when I see a tangent or a cotangent value of 1 because they're both y over x or x over y. Well, if it's simplifying to 1, that means that the x and the y value have to be the same number. So which of my triangles is the x and the y value the same number? The 45, 45, 90 triangle. So this tells me 45-degree reference angle. Cotangent is negative. That happens when the x and the y values are opposite signs, and that happens in quadrants 2 and 4. And now we just have to figure out what those actual angle measures are. So this is 45 degrees less than 180, 135 degrees, and this is 45 degrees less than 360, 315 degrees. And if we were putting that in radian, we'd have 3 pi over 4 and 7 pi over 4. Because later when we are solving trig equations, we're going to have to go, this step to this step is going to be our last step when solving equations, and we're going to have to do it over and over and over again. So both directions, super important. Questions? So the last thing I want to do relevant to unit circle is just go over the beautiful color-coded unit circle that I have created for you. This is not the one posted in your book. It's posted online though as like an additional resource. And if it's not, I'll post it. So again, I've color-coded it because I love to color-code things because it helps me follow the patterns. So here you'll notice that I have 4 that are red. These are all the triangles with a 30-degree reference angle. And you'll notice that the ordered pairs are the same. They're in the same order. It's just whether the x value is positive or negative has changed. So anytime you have a 30-degree reference angle, your ordered pair is square root of 3 over 2 comma 1/2. But honest, I picture this triangle every time, and I'm like, short side or long side every time, and then I don't have to memorize it. When I was a student, I just totally memorized it, but you saw the trig teacher I was working with. He just gave us this sheet and said, memorize it. Don't try to understand it. Crazy. The green ones, these are our 45-degree reference angles. You'll notice that its ordered pairs have the same value, both square root of 2 over 2. It's just the positive and negative that changes. And then the purple ones, that's where we have a reference angle of 60 degrees. And those ordered pairs have all the same values, 1/2 comma square root of 3 over 2. It's just the positive and the negative that is changing. Sometimes students have trouble remembering the radian. So here's a way to help you count the radian so that you're not having to do conversions every single time. I'm going to do the green ones first, the 45-degree reference angles. 45 degrees, that's pi over 4. 90 degrees, well, that's double, right? Double 45. So this is 1 pi over 4. This is 2 pi over 4, which simplifies to pi over 2. This is 3 pi's over 4. This is 4 pi's over 4, which simplifies to be just pi. 5 pi over 4. 6 pi over 4, which simplifies to be 3 pi over 2. 7 pi over 4. And then 8 pi over 4, which simplifies to be 2 pi. So that way we can count around more easily our radian measure. Now I'm going to do the other ones. And I can actually do them together because I'm going to start with 30, but notice 60 is just double 30, right? 30 plus another 30 is 60, plus another 30 is 90. So I'm going to count around, excuse me, by pi over 6s. So this is 1 pi over 6. 60 degrees is going to be 2 pi over 6, which simplifies to be pi over 3. 90 degrees is 3 pi's over 6, which simplifies to be pi over 2. 4 pi's over 6 simplifies to be 2 pi over 3. 5 pi over 6. 6 pi over 6 simplifies to be just pi. And then I keep going. 7 pi over 6. 8 pi over 6, which simplifies to 4 pi over 3. See, and then I just lost count, so now I'm going to do it again. So 1, 2, 3, 4, 5, 6, 7. Okay, 8. 9 pi over 6 simplifies to 3 pi over 2. 10 pi over 6 simplifies to 5 pi over 3. 11 pi over 6. And then 12 pi over 6 simplifies to 2 pi. So that's another way that you can help with your radian around your unit circle. Okay, so that is the end of my thorough unit circle discussion. I hope you found it helpful.